July 2nd, 1944, Yokosuka Naval Air Technical Arsenal, Japan. The morning sun reflected off polished aluminum as Lieutenant Commander Saburo Sakai approached an aircraft that would shatter everything Japanese naval aviation believed about American fighter design. The Grumman F6F Hellcat sat on the tarmac like a monument to an engineering philosophy that contradicted 2 decades of Japanese aeronautical doctrine. Its size alone felt like a provocation. Where the Mitsubishi A6M Zero was slender, elegant, and impossibly light, a dancer in the sky, the Hellcat appeared almost brutish. It looked heavy, imposing, deliberate. It resembled less a fighter plane and more a flying fortress of machinery. 18 cylinders, 2,000 horsepower, armor plating thick enough to stop 20-millimeter cannon shells, a canopy made from bulletproof glass that weighed more than the entire tail section of the Zero. It was the polar opposite of everything Japanese designers believed a fighter should be. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Sakai had flown the Zero into some of the war's fiercest dogfights. He revered its agility, its range, its ability to outturn any opponent. But he had also seen its weaknesses, felt its fragility. The Zero was a masterpiece of offensive capability, but it was unforgiving, brittle, and merciless to its own pilots. It had no armor, no self-sealing fuel tanks, no redundant systems. A few well-placed bullets could turn it into a funeral pyre. The Hellcat had no such concerns. It was designed to keep pilots alive. When Sakai climbed into the cockpit, he noticed the difference immediately. The controls were practically luxurious. Padded seat, ergonomic layout, large instruments spaced for quick reading, even in turbulence. Japanese cockpits were cramped and Spartan, designed for minimal weight, not pilot comfort. But here, every detail seemed engineered to protect the man, not just optimize the machine. He throttled up for takeoff and felt the double Wasp engine roar, a deep, muscular sound unlike the smoother hum of Japanese engines. The Hellcat surged forward with effortless power. It did not leap into the air like a Zero. It climbed like a locomotive on wings, steady and unstoppable. At altitude, he tested its handling. No, it could not outturn a Zero. No, it could not execute the elegant floating maneuvers that defined Japanese aerial combat. But it could dive, and not just dive, it could plummet. The Zero, made from lightweight materials, risked tearing its wings off in a steep dive. The Hellcat, despite its size, cut through the air like a falling blade. Its robust airframe, braced with thick skin and armor reinforcement, allowed American pilots to escape at will. Dive, survive, regroup, strike again. That single capability, the ability to leave combat alive, was revolutionary. Sakai had always believed that dogfighting was about skill, nerve, and spirit. The Hellcat challenged that belief. It was not designed to win through elegant flying. It was designed to win through durability, firepower, and survivability. Its 6 .50 caliber machine guns could shred a Zero before the Japanese pilot even got close enough to maneuver. And if the Zero did return fire, the Hellcat could take it. The Zero could not. In that 90-minute flight, Sakai came to a startling realization. The Americans had not built a fighter. They had built a system. The Hellcat was not just an aircraft. It was the physical embodiment of an industrial doctrine. Its parts were standardized, interchangeable, easy to repair. In American factories, the same wing section could be installed on any Hellcat anywhere in the world. Repairs could be completed in hours, not days. The Japanese could barely maintain their aircraft by the final year of the war. The Americans could rebuild fleets. Sakai returned the Hellcat to the runway with the uneasy awareness that he had just flown the future. When he entered the briefing room, senior aviation officers expected him to deliver details, handling characteristics, performance metrics, turning radii, stall speed, service ceiling, and other familiar data points he had always provided after fighter tests. But this time, he spoke differently. He did not talk only about airspeed. He talked about production speed. He did not talk only about maneuverability. He talked about pilot survivability. He did not talk only about craftsmanship. He talked about standardization. He explained how Grumman engineers had designed the Hellcat to be manufactured by thousands of factory workers, many with no aviation experience, across dozens of states. He explained how field armorers could replace damaged components in under an hour, using nothing more than simple tools and a set of instructions even a junior mechanic could follow. He pointed out that the Hellcat's protective armor did not just save lives, it preserved pilot experience. In American squadrons, a damaged plane could be replaced. A dead pilot could not. Japanese commanders quietly listened. They wanted technical evaluation. They received industrial evaluation. Sakai told them something no pilot was supposed to say. We cannot beat this airplane. Not because it turns better or climbs faster, but because it brings its pilots home, and it comes back in greater numbers than we can destroy. It was not the kind of report Japanese leadership wanted to hear, but it was the kind of report they needed. That day, in Yokosuka, an uncomfortable truth settled over the assembled officers, perhaps for the first time since the war began. Japan had not lost control of the skies because its pilots lacked courage or skill. It had lost because it could not build machines that matched American reliability. It could not replace pilots as fast as America could. It could not protect the pilots it did have. War in the air was no longer just about maneuvering in the clouds. It was about factories. A fighter did not have to be the fastest if it could be the most survivable. It did not need the tightest turning radius if it had rugged armor, self-sealing tanks, and a strong airframe. The Zero was a sword. It could strike beautifully, precisely, lethally. The Hellcat was something different. It was a hammer. And a hammer does not have to be elegant to break things. By the time the war ended, the Americans had built more than 12,000 Hellcats. Japanese industry had produced barely a fraction of that number of modern fighters. And while American training schools produced thousands of new pilots annually, Japan struggled to keep even its few aces alive. Saburo Sakai survived the war, one of the few legendary Japanese pilots to do so. He never forgot his time in the Hellcat. Years later, he would describe it not as a machine, but as a message, an airborne declaration of how wars would now be fought. We designed fighters for performance, but, he once said, they designed fighters for survival. That is why they won. What he had truly seen that morning at Yokosuka was not the triumph of American aviation. It was the triumph of American philosophy, a philosophy that believed machines must protect the men who use them, a philosophy that believed wars were not won by heroes alone, but by the systems that preserved those heroes, a philosophy that believed survival was not cowardice, it was strategy. And that was the difference. The Zero was a beautiful weapon. The Hellcat was a winning one. The Hellcat had arrived at Yokosuka 3 weeks earlier, recovered from shallow waters off Saipan, where its pilot had ditched after running out of fuel during combat operations. Japanese salvage crews had retrieved the aircraft nearly intact, its massive Pratt & Whitney R2800 engine requiring only minor repairs before ground tests confirmed full operational capability. Now, Imperial Japanese Navy Command wanted answers. How had American pilots flying aircraft that violated every principle of fighter design achieved kill ratios that threatened Japan's entire defensive strategy across the Pacific? Sakai possessed qualifications that made him uniquely suited for this evaluation. 32 years old, 2,000 combat hours logged since 1937, 64 confirmed victories earned over China, the Philippines, and the Solomon Islands. He had engaged American fighters in every major campaign from Pearl Harbor through the Marianas Turkey Shoot 6 weeks earlier, accumulating tactical knowledge that separated elite aviators from replacement pilots whose life expectancy measured in days rather than months. But statistics and combat experience could not prepare any Japanese pilot for what 90 minutes in an American fighter would reveal about the technological and industrial gulf separating the two nations. The tactical implications would extend far beyond immediate military considerations, forcing recognition of industrial capacity differences that no amount of courage or tactical skill could overcome. The pre-flight inspection revealed design priorities that challenged fundamental assumptions underlying Japanese aircraft development. The Hellcat's fuselage incorporated armor protection that surrounded the pilot in a steel cocoon weighing over 300 pounds. Fuel tanks featured self-sealing technology that Japanese engineers had dismissed as unnecessary weight, adding complexity without meaningful performance benefits. The cockpit itself contained more instrumentation than Sakai had seen in squadron-level command posts, with gauges monitoring engine parameters that Japanese aircraft treated as optional information. Every component spoke to a design philosophy that prioritized pilot survival over aircraft performance, a conceptual approach that Japanese military doctrine had explicitly rejected in favor of offensive capability and tactical flexibility. The Zero had dominated Pacific skies through 1942 by accepting vulnerabilities that American designers considered unacceptable. No armor protection meant more ammunition. No self-sealing fuel tanks meant longer range. Minimal instrumentation meant reduced weight and improved maneuverability. The trade-offs had produced an aircraft that could outfly anything in the American inventory during the war's opening phase. But 3 years of brutal attrition warfare had revealed flaws in this philosophy that cost Japan hundreds of irreplaceable veteran pilots. Aircraft that burst into flames from single incendiary rounds, pilots who died from wounds that armor protection would have prevented, fuel systems that exploded under hits that self-sealing tanks would have contained. The tactical advantages gained through lightweight design had been purchased with pilot lives that Japan's limited training infrastructure could not replace. Sakai climbed into the Hellcat's cockpit, noting immediately how the armored seat and bulletproof glass created a protected fighting position rather than an exposed platform for aerial combat. The control layout reflected American engineering pragmatism, with large, clearly labeled switches positioned for operation while wearing heavy gloves. The throttle quadrant felt solid under his hand, its mechanical linkage conveying precision that suggested robust construction throughout the aircraft systems. The R2-800 engine fired with a deep rumble that vibrated through the entire airframe, its 18 cylinders producing power that exceeded any Japanese fighter by 40%. Sakai advanced the throttle, feeling acceleration that pushed him back in his seat with force that seemed impossible for a fighter aircraft. The Hellcat began its takeoff roll, building speed rapidly as the massive engine converted fuel into forward motion with brutal efficiency. At 65 knots, Sakai pulled back on the stick. The Hellcat rotated smoothly, its wide-track landing gear providing stability that Japanese aircraft with their narrow stance could never match. The aircraft climbed away from Yokosuka at a rate that defied everything Sakai's experience told him about fighter performance. 3,000 feet per minute, altitude that took the Zero nearly 3 minutes to achieve, disappeared beneath the Hellcat in 60 seconds. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The realization began during that initial climb as Sakai processed performance data that contradicted 2 decades of Japanese fighter development philosophy. The Americans had not built a fighter optimized for dogfighting excellence. They had engineered a weapons platform designed to hunt and destroy enemy aircraft through systematic application of superior performance across multiple parameters. The Hellcat could not turn with a Zero, but it did not need to turn with a Zero. It could climb faster, dive faster, sustain higher speeds in level flight, and absorb battle damage that would destroy lighter aircraft. At 10,000 feet, Sakai leveled off and began the systematic evaluation that would consume the next 90 minutes. He pushed the Hellcat into a series of combat maneuvers, testing its response to inputs that would have pushed the Zero to its structural limits. The American fighter accepted punishment that should have torn wings from fuselage, its robust construction enabling tactical options that Japanese aircraft could not safely attempt. A 4G turn that would have stressed the Zero's airframe to maximum design limits felt comfortable in the Hellcat. Sakai pushed harder, pulling 6Gs in a sustained turn that should have produced structural warnings. The aircraft responded smoothly, its heavy construction absorbing loads that demonstrated fundamental differences in design and safety margins. American engineers had built an aircraft that could withstand combat maneuvering while carrying full combat loads, protecting pilots through structural integrity rather than expecting them to fly within narrow performance envelopes that offered no margin for error. The tactical implications crystallized as Sakai completed his evaluation of the Hellcat's turning performance. Japanese doctrine emphasized dogfighting skills developed through thousands of training hours that taught pilots to exploit the Zero's superior maneuverability. But American pilots did not need to dogfight when their aircraft could dictate engagement terms through performance advantages in every combat-relevant parameter except instantaneous turn rate. Sakai pushed the Hellcat into a dive, watching airspeed indicators climb past 350 miles per hour, then 400, then 450. The Zero would have reached structural limits at 380 miles per hour, forcing Japanese pilots to abandon diving attacks before achieving speed advantages that could be converted into tactical superiority. The Hellcat dove through 450 miles per hour with control harmony that suggested it was nowhere near maximum design speeds. This single characteristic negated decades of Japanese tactical development. American pilots could attack from superior altitude, building speed through diving approaches the Japanese aircraft could not match. If the engagement turned unfavorable, American pilots could extend away from combat through diving acceleration that left pursuing Zeros behind, unable to follow without exceeding structural limits that would destroy their aircraft. The tactical cycle could be repeated indefinitely, with American fighters controlling engagement timing, while Japanese pilots reacted to attacks they could not prevent or pursue. The 6.50 caliber Browning machine guns installed in the Hellcat's wings represented another revelation that challenged Japanese assumptions about fighter armament. Japanese fighters typically mounted two 7.7mm machine guns and two 20mm cannons, a configuration that provided devastating firepower within the cannon's limited ammunition capacity. The Hellcat's 6 machine guns could fire for nearly 20 seconds continuously, delivering over 2,400 rounds of armor-piercing incendiary ammunition that could shred enemy aircraft through sheer volume of fire. Sakai test-fired the guns during his evaluation, feeling the aircraft shudder as 50 caliber rounds departed at over 2,600 feet per second. The convergence pattern created a cone of destruction that required only approximate aiming to strike targets, contrasting sharply with Japanese cannon armament that demanded precise fire control to make limited ammunition count. American pilots could afford to fire longer bursts, compensating for aiming errors through ammunition capacity that Japanese fighters could not match. But the most devastating revelation came when Sakai evaluated the Hellcat's fuel system during extended maneuvering that should have created vulnerability to catastrophic failure. He had witnessed dozens of Japanese aircraft explode into fireballs after single hits to unprotected fuel tanks, their pilots dying instantly as aviation gasoline ignited from tracer rounds or incendiary ammunition. The Hellcat's self-sealing tanks represented technology the Japanese industry had failed to develop despite years of combat experience, demonstrating its necessity. Sakai performed violent maneuvers designed to slosh fuel through the tank's internal structure, evaluating how the self-sealing liner responded to movement that might compromise its integrity. The system functioned flawlessly, providing protection that would allow damaged aircraft to return to base rather than burning in the sky above enemy territory. The psychological impact of this technology on American pilot morale could not be quantified, but Sakai understood intuitively that pilots who expected to survive combat damage would fight more aggressively than aviators who knew that any hit might prove fatal. The instrument panel revealed another dimension of American technological superiority that extended beyond pure aircraft performance. The Hellcat carried electronic identification systems that marked friendly aircraft on shipboard radar displays, enabling fleet defense coordination impossible with Japanese technology. Radio equipment provided clear communications across distances that reduced Japanese transmissions to static-filled fragments. Navigation instruments included directional gyros and attitude indicators that enabled instrument flight through weather conditions that would ground Japanese formations, relying on visual references. Every system reinforced a central theme that Sakai had begun recognizing during his initial climb from Yokosuka. The Americans had industrialized aerial warfare, creating weapon systems that reduced individual pilot skill requirements while maximizing combat effectiveness through technological superiority. Japanese aviation doctrine emphasized elite pilot training that produced aviators capable of extraordinary feats in lightweight, maneuverable aircraft. American doctrine assumed average pilot skills supported by aircraft that compensated for limited experience through performance advantages and protective systems. The strategic implications of this philosophical difference had become apparent through 3 years of attrition warfare that Japan could not sustain. Training a pilot to Sakai's skill level required 2 years and thousands of flight hours that consumed fuel and aircraft Japan's economy could not replace. American training programs produced combat-ready pilots in 6 months, relying on aircraft capabilities rather than extraordinary skills to achieve tactical success. The mathematics favored industrial capacity over individual excellence in conflicts measured by years rather than battles. After 60 minutes of systematic evaluation, Sakai had documented performance characteristics that explained American tactical dominance throughout the Pacific with uncomfortable clarity. The Hellcat represented not just superior aircraft design, but fundamental advantages in industrial capacity, technological development, and strategic resource allocation that Japan could not match, regardless of tactical skill or warrior spirit. He began the landing approach to Yokosuka with thoughts already focused on the briefing that would follow his flight evaluation. The report he would deliver to Imperial Navy commanders would contradict official assessments that attributed American success to numerical superiority rather than qualitative advantages. The truth was more disturbing. American industry had solved problems that Japanese engineers had struggled with for years, creating weapon systems that negated tactical skills through systematic application of overwhelming technological superiority. The Hellcat touched down smoothly, its wide landing gear stance providing stability during rollout that demonstrated attention to operational details Japanese designs had sacrificed for performance. Sakai taxied to the evaluation area where senior officers waited for his preliminary assessment, their expressions revealing expectations that this flight would confirm existing beliefs about American fighter capabilities. What they would hear, instead, would challenge fundamental assumptions about Japan's ability to continue fighting a war that industrial metrics suggested was already lost. The briefing room at Yokosuka Naval Air Technical Arsenal contained 12 officers representing Imperial Navy Aviation Command Structure, from squadron leaders to staff officers responsible for strategic planning. Their collective combat experience exceeded 300 years, encompassing operations from China through the current campaigns defending Japan's inner defensive perimeter. They had gathered to hear technical specifications and performance data that would guide tactical recommendations for countering the Hellcat threat. Sakai stood before them, carrying knowledge that transcended technical analysis to address strategic realities that military culture discouraged acknowledging openly. He began with factual observations that documented the Hellcat's performance characteristic, allowing numbers to establish baseline understanding before introducing conclusions that would challenge comfortable assumptions about American capabilities. Maximum level speed at 19,000 feet, 380 miles per hour. Initial climb rate, 3,100 feet per minute. Service ceiling, 37,000 feet. Combat range with standard fuel load, 945 miles. The specifications alone exceeded zero performance in every category except turning radius. But Sakai continued with observations that revealed deeper implications. The aircraft incorporates the armor protection, totaling 320 pounds, that surrounds the pilot's position in overlapping plates, capable of defeating 20mm cannon fire at combat ranges. Fuel tanks feature self-sealing construction that contains leaks from multiple hits. The cockpit canopy uses bulletproof glass that stopped test rounds from 7.7mm machine guns fired at point-blank range. Captain Minoru Genda, one of Japan's most respected aviation tacticians and principal architect of the Pearl Harbor attack plan, interrupted with a question that reflected concerns shared by everyone present. These protection systems add significant weight. How does this aircraft achieve superior performance while carrying such defensive measures? Sakai had anticipated this question, recognizing it as the central paradox that Japanese aircraft designers had struggled to resolve. The R2-800 engine produces 2,000 horsepower at takeoff, compared to 1,140 horsepower from our Nakajima Sake engine. American industry has solved metallurgical and cooling problems that have prevented our engineers from achieving similar output from comparable displacement. The additional power overcomes weight penalties from protective systems while maintaining performance advantages across all speed regimes. The response generated discussion among officers who understood that engine technology represented industrial capability rather than design philosophy choices. Japanese factories could not produce engines matching American power output because they lacked access to metallurgical processes, precision manufacturing equipment, and quality control standards that American industry had developed through decades of automotive production scaled to aviation requirements. Commander Yoshio Yamaguchi, Chief of Fighter Development for the Naval Air Technical Arsenal, raised the implication everyone recognized but military protocol discouraged, stating directly, "If American industry can produce fighters with such performance advantages in sufficient quantities, our tactical doctrine requires fundamental revision. The Zero's maneuverability advantages become irrelevant if enemy aircraft can dictate engagement terms through superior speed and climb rate." Sakai nodded, appreciating Yamaguchi's willingness to acknowledge what combat reports had documented for 18 months. "I engaged Hellcats over the Philippine Sea during the air battles 6 weeks ago. Our pilots achieved initial surprise through tactical coordination, but American formations recovered quickly and established air superiority through systematic application of superior aircraft performance. They climbed above our formations, dove through our defensive circles, and extended away from counterattacks before our aircraft could establish firing positions. Our 64 aircraft losses against their 18 represented not poor pilot skill, but technological disadvantages that tactical excellence cannot overcome. The Marianas Turkey shoot had decimated Japanese carrier aviation, destroying over 300 aircraft, while American losses numbered fewer than 30. Official reports had attributed the disaster to inadequate pilot training among replacement aviators rushed into combat without proper preparation. Sakai's analysis suggested that even experienced pilots flying Zeros could not overcome performance disadvantages that the Hellcat's design specifically targeted. Captain Genda pursued the strategic implications with questions that military culture typically deflected through references to fighting spirit and tactical innovation. "Your assessment suggests we cannot achieve favorable exchange rates against American fighters under current conditions. What tactical modifications might restore combat effectiveness?" The question acknowledged defeat while searching for solutions that would allow continued operations despite inferior equipment. Sakai appreciated Genda's pragmatism, but recognized that honest analysis required confronting uncomfortable truths about industrial capacity differences that tactical adjustments could not address. American production will deliver over 12,000 Hellcats this year. Our factories will produce approximately 1,500 Zeros during the same period. Even if we achieved parity in exchange rates, which current performance disparities make impossible, simple mathematics demonstrate that attrition warfare favors the nation with greater industrial output. American pilot training programs graduate over 100 combat-ready aviators monthly from facilities in Florida alone. Our primary training academy at Tsuchiura cannot replace pilots at rates matching current losses. The silence following this observation reflected recognition that Sakai had articulated realities that strategic planning documents had avoided stating explicitly. Japan had entered war with the United States, assuming that early victories and American unwillingness to sustain casualties would produce negotiated settlement before industrial advantages became decisive. 3 years of combat had demonstrated that American determination matched their production capacity, creating conditions where Japanese courage and tactical skill could not compensate for quantitative disadvantages in both equipment and personnel. Admiral Jisaburo Ozawa, commander of Japan's remaining carrier forces, and participant in the briefing through secured telephone connection from Combined Fleet Headquarters, asked the question that would define Japan's remaining options. Lieutenant Commander Sakai, having evaluated American fighter capabilities against our finest aircraft, what recommendation do you offer regarding continued prosecution of aerial warfare against the United States Navy? The question invited military-appropriate response that would acknowledge challenges while affirming determination to achieve victory through superior spirit and tactical innovation. But Sakai had spent 90 minutes understanding that American engineering had systematically negated advantages that Japanese aviation had cultivated through decades of development. His answer would violate protocol that discouraged defeatist analysis, but intellectual honesty and respect for fellow pilots demanded truth rather than comforting fiction. Admiral, the Hellcat represents technological sophistication that our industrial capacity cannot match within timeframes relevant to current strategic situation. American aircraft carriers will deploy squadrons equipped with fighters superior to our best aircraft in every performance category. Their pilots, though less experienced than our veterans, fly aircraft that compensate for skill differences through protective systems and performance advantages. Most significantly, American industry can replace losses at rates that will maintain numerical superiority regardless of tactical outcomes. Sakai paused, recognizing that his next statement would exceed boundaries that military culture established around acceptable analysis. Continued aerial combat against the United States under current conditions will destroy Japanese naval aviation through attrition that our training infrastructure cannot replace. We face an opponent whose industrial capacity exceeds our own by factors that courage and tactical skill cannot overcome. I respectfully submit that operational planning must acknowledge these realities rather than pursuing strategies that assume technological parity that does not exist. The recommendation stopped just short of explicit suggestion that Japan seek negotiated settlement, but everyone present understood the implications. If Japanese aviation could not achieve tactical success against American forces, and if industrial capacity differences prevented replacing losses, then continued combat would exhaust remaining military capability without achieving strategic objectives that might improve negotiating position. Admiral Ozawa's response came after lengthy silence that suggested consultation with staff officers at Combined Fleet Headquarters. Lieutenant Commander Sakai, your analysis provides valuable intelligence regarding American fighter capabilities. However, strategic decisions remain beyond operational planning scope. You will prepare detailed technical report documenting the Hellcat's performance characteristics for distribution to fighter units throughout the Pacific. Command appreciates your professional assessment. The statement acknowledged Sakai's recommendations while declining to pursue their logical conclusions, a response that reflected institutional constraints preventing military organizations from advocating policy positions that civilian authority considered beyond their purview. But the briefing had accomplished something more significant than immediate tactical recommendations. Senior officers responsible for Japanese naval aviation had heard direct assessment that American technological superiority could not be overcome through fighting spirit or tactical innovation. The technical report that Sakai completed during subsequent weeks circulated through Japanese fighter units with classified distribution that reached squadron commanders throughout the Pacific. Pilots who had engaged Hellcats in combat recognized Sakai's observations as confirmation of experiences they had struggled to explain through tactical frameworks that assumed rough performance parity between opposing fighters. The psychological impact proved more significant than immediate tactical adjustments. Japanese aviators who had dominated Pacific skies during the war's opening campaigns now confronted evidence that American industry had solved problems that Japanese engineers could not address. The invincibility that had characterized Japanese naval aviation through 1942 had been purchased through qualitative superiority that no longer existed. Future combat would require accepting disadvantages that skill and courage could mitigate but not overcome. By August 1944, the strategic situation had deteriorated beyond recovery through tactical excellence. The Battle of the Philippine Sea had destroyed Japanese carrier aviation as an effective offensive force. American submarines had severed supply lines that connected Japan's industrial centers with raw material sources in Southeast Asia. Strategic bombing campaigns against Japanese cities would begin within months, enabled by B-29 bombers operating from bases that Japanese forces could no longer contest. Sakai's 90-minute evaluation of the Hellcat had provided quantitative confirmation of qualitative disadvantages that extended across Japan's entire military-industrial complex. American factories produced not just better aircraft, but superior tanks, ships, artillery, and electronic systems that reflected industrial capacity differences that no amount of warrior spirit could overcome. The recognition came too late to influence strategic decisions that might have produced more favorable outcomes, but it documented the technological and industrial realities that would shape warfare throughout the remainder of the 20th century. The test flight itself became part of classified history that emerged only after Japan's surrender in August 1945. Sakai survived the war, one of few Japanese aces who lived to describe aerial combat against opponents whose industrial power had transformed warfare from contests of individual skill into systematic application of overwhelming material superiority. His post-war writings would describe the Hellcat evaluation as the moment when he understood that Japan had committed itself to a conflict that industrial metrics suggested was unwinnable from its inception. The broader lesson transcended immediate historical circumstances to address fundamental questions about technology, industrial capacity, and strategic decision-making. The Hellcat represented more than superior aircraft design. It embodied American industrial philosophy that treated warfare as engineering problem, requiring systematic solutions rather than arena for demonstrating martial virtue. Japanese cultural values that emphasize spiritual superiority and warrior excellence had encountered opponent whose strength derived from factories, supply chains, and mass production techniques that reduced warfare to industrial output measured in tonnage produced and weapons deployed. Lieutenant Commander Saburo Sakai's 90-minute test flight in a captured Grumman F6F Hellcat was supposed to be a technical exercise, an evaluation of enemy hardware. One more data point. In a war fought increasingly through engineering reports and performance charts, but it became something more. For Sakai, Japan's most renowned surviving fighter ace, it was a revelation. The test flight confirmed what frontline pilots had whispered for months, often in quiet conversations, held far from the attentive ears of senior officers. The Americans had not prevailed through superior bravery, tactical sophistication, or pilot skill, qualities Japanese aviators had believed were their nation's unquestioned strengths. They had won because they had built better machines, protected their pilots, and designed a system. Not a series of airplanes, but a methodology for producing, deploying, and sustaining them, that Japan's industrial base simply could not rival. The Hellcat was not graceful. It did not climb like the Zero, nor did it turn with the same elegant precision, but it was something the Zero could never be. Stable, forgiving, resilient, and engineered to keep the man inside alive. It could take hits, it could dive faster than any Japanese fighter without falling apart, it could be repaired quickly, and most importantly, it could be built in numbers that left Japanese planners shaking their heads in disbelief, refusing to confront arithmetic that seemed almost magical. Grumman had built more than 100 Hellcats per week at peak production. That was more fighters in 7 days than Japan could produce in an entire month. The Japanese aviation elite had spoken endlessly about pilot spirit, discipline, and courage. The Americans had spoken about tooling, tolerances, maintenance cycles, logistics, and pilot survivability. Only one of these approaches had proven decisive. Sakai described these facts not emotionally, but clinically, like a surgeon outlining the cause of death. The Hellcat's cockpit layout was intuitive. Its control surfaces were heavy but predictable, giving pilots feedback rather than simply demanding strength. It had armor plate, heavy sheets of steel protecting its fuel tanks and cockpit. Japanese designers had debated whether such armor was worth the wait. The Americans had concluded that bringing pilots home alive was not simply morally correct, but strategically essential. A pilot who survived could fly again. A pilot who died took his training, experience, and tactical learning with him to the grave. Survival was not an incidental feature of American aircraft. It was a design priority. In the briefing room at Yokosuka, where Navy engineers and veteran pilots gathered to hear Sakai's evaluation, something extraordinary happened. He spoke not in triumph or defeat, but with the clarity of someone who had glimpsed the fundamental truth behind the entire conflict. This war would not be decided in dogfights, where skill and bravery still mattered. It would be decided in factories, places where battles were fought with stamping presses, jigs, casting furnaces, and standardized parts. Sakai explained how the Hellcat's modular construction allowed entire sections to be swapped out instead of painstakingly repaired. He spoke of its engine, not as a pilot, but as a student of engineering. The Pratt & Whitney R2800 Double Wasp, rugged, powerful, and designed to keep running even after absorbing extensive damage. He described how the cockpit canopy provided clear, wide visibility, not just forward, as in the Zero, but in all directions. American pilots could see behind them, reducing surprise attacks. The Hellcat's wings were thick enough to conceal armored fuel tanks and folding mechanisms, reflections of a carrier doctrine Japan had pioneered but failed to fully master. The Hellcat represented a design philosophy Japan had never adopted: build not the perfect fighter, but the one that wins wars. Japan's finest pilots had believed the Zero was the perfect aircraft, light, fast, and maneuverable, and at the beginning of the war, it had been revolutionary. But while the Zero remained essentially unchanged throughout the conflict, the Americans evolved. The Hellcat, the Corsair, the Mustang, each was faster, stronger, more durable than its predecessor. They were not just machines. They were iterations of doctrine, reflections of a system where feedback flowed from the battlefield to the factory floor with astonishing speed. Every weakness observed in combat became a design correction in the next batch of planes. The Americans did not merely design aircraft, they industrialized adaptation. Sakai, who had downed more than 60 enemy aircraft in combat, was not humbled by the Hellcat. He was enlightened by it. He knew that if he had fought this machine in combat, he could have defeated it once, perhaps even a few times. But he also knew that while he was fighting one Hellcat in the air, 20 more were being built on Long Island, and even if he shot one down, its pilot might survive, to fight again. Japan could not match that arithmetic. War, Sakai said, had become mathematics, and Japan had already lost the equation. When he finished describing his flight, there was silence, not the contemplative silence of men thinking, but the stunned silence of officers realizing that what they had believed for years, that quality of spirit could overcome material disadvantage, was no longer true. It had not been true for a long time. They had simply refused to see it. One test pilot in the room spoke up, his voice barely above a whisper. He said, simply, "We should not fight them anymore." He did not say this as a coward or defeatist. He said it as a professional aviator who now understood that the enemy was not merely flying better machines, he was operating inside a system of war so advanced that courage, skill, and determination could no longer compensate for its advantages. But the truth could not be accepted. Not fully, not publicly. Japan's military culture was rooted in notions of honor, sacrifice, and indomitable spirit. It was one thing to lose and so battle. It was another to accept that the very way one conceived of war was wrong. Political reality offered even less room for such heresy. The idea that Japan could not simply train harder, fight better, and attack with greater intensity contradicted everything the High Command believed, or needed to believe. So, the truth rested in rooms like this one, spoken quietly, among those who understood machines, not slogans. Men like Sakai, who had seen the limits of courage when facing industrial superiority. He had taken off in a borrowed Hellcat and landed understanding something fundamental. The Americans were not fighting the war Japan believed in. They were fighting a different war entirely, one defined not by the courage of individuals, but by the strength of systems. In the end, atomic weapons forced the recognition that could not be reached through reports, briefings, or first-hand accounts. But long before Hiroshima and Nagasaki, the truth had been visible in aircraft like the Hellcat, in engines that refused to fail, in pilots who returned to battle again and again because their nations had decided that protecting them was not optional. Lieutenant Commander Saburo Sakai had not merely taken the controls of an American fighter. He had stepped inside an entirely different way of thinking about war. In that cockpit, surrounded by armor plating, self-sealing tanks, redundant controls, and thick, bulletproof glass, he realized that American engineers had designed a weapon not just to fight, but to preserve the life of the person fighting. They had built airplanes not as instruments of glory, but as instruments of endurance. Strength was not measured in agility or elegance, but in survivability and repeatable reliability. Sakai understood then that America had not won by producing superior individual pilots or more daring tacticians. They had won by designing machines that compensated for human limits rather than demanding perfection from their operators. American technology did not require flawless flying. It allowed for mistakes. It forgave errors. It protected those inside it so they could fly again tomorrow and the next day and the day after that. While Japanese aces vanished from the war one by one, he realized the Japanese machines were built for heroes, but American machines were built for soldiers. The Zero had been crafted for the exceptional pilot, the 1 in 1,000 master of aerial combat. But war is not fought by 1 in 1,000. War is fought by the many. And that was what the Hellcat represented, not the triumph of the individual, but the triumph of the system. The war had not been lost in the skies over the Pacific. It had been lost in Detroit, in Buffalo, in Seattle, in places where men and women who would never fly an airplane built them by the tens of thousands. The war had been lost not in dogfights, but in blueprints, assembly lines, and logistical networks, long before the first shot was fired. Up next, we have 2 more incredible stories that are waiting for you. Just click the image you want to watch, and it will take you there. If you enjoyed this video, make sure to subscribe. It would mean a lot.